Good afternoon, students. Today we are going to discuss deadlock characterization. That means in a deadlock, processes never finish executing. Okay, that means whenever the deadlock is occurred, the processes never finish its execution because of one process holds some resource and other process is waiting for that. So that other process hold for particular resource. Now that is wait for other resource, other process. So this is the continuous process. So that in a deadlock, processes never finish their execution. So because of that reason, system resources are very tied up. That is preventing other jobs from starting. Okay, so that means what? Whenever the deadlock is occurred, processes are never finished their execution. So in this situation, system resources are going to tied up, so that preventing other jobs from starting. Here, before there is before we discuss how to handle these deadlocks, that means here various methods are there to handle the deadlocks. So first of all, we have to discuss about deadlock characterization. So now the deadlock characterization here, deadlock can arise if four conditions hold simultaneously. That is, if four conditions hold simultaneously, a deadlock situation may arise. That is, mutual exclusion, hold and wait, no preemption, circular wait. So here coming to this mutual exclusion, only one process at a time can use the resource. That is, at least one resource must be held in a non-shareable mode. So that is only one process at a time can use the resource. That is what? At a time, that means non-shareable resource. Non-shareable resource in the sense what? Here, non-shareable resource. If the non-shareable resource is there, this non-shareable resource handle by the process. That means at a time, only one process at a time can use this non-shareable resource, in the sense only one process at a time can use. Only one process at a time can use this resource. That is called as non-shareable resource. Non-shareable in the sense what? Only one process at a time can use the resource. Okay. So this is called as a non-shareable resource. That means mutual exclusion aggravali ante kachithanga manaki em undali, at least one resource must be held in a non-shareable mode. At least one resource. That means suppose out of number of resources, at least one resource held in a non-shareable mode. Okay. So non-shareable mode is in the sense what? That means only one process at a time use that resource. If other process requests the resource, the requesting process must be delayed. That means suppose other process here, suppose this is a non-shareable resource. This is what the non-shareable resource. Here this process P1 hold this non-shareable resource. So whenever this process P2 try to hold this non-shareable resource, okay, if another process requests that resource, the requesting process must be delayed until the resource has been released. This requesting process must be delayed. That means this start avadu. Enduku start avadu ante this requested process must be delayed because this resource released by this process until the resource is released by another process. That means another process in the sense which process hold that resource. This is a non-shareable, means what? At a time these two processes are not use this resource. This is called as a non-shareable resource. So if P2 suppose this P2 is decided use this resource, but this resource is already used by the process P1. సో దట్ దిస్ ఈస్ నాట్ పాసిబుల్ అంటిల్ ఇది రిలీజ్ చేసేంత వరకు ఈ రీసోర్స్ ఇక్కడ యూజ్ అవ్వదు. సో దిస్ ఈస్ వాట్ ద మ్యూచువల్ ఎక్స్క్లూషన్. సో దిస్ ఈస్ కాల్డ్ యాజ్ ఏ mutual exclusion. Now here this is what the mutual exclusion. Now coming to hold and wait. What is a hold and wait? We know that very well, this hold and wait. So a process must be holding at least one resource and waiting to acquire the additional resources that are currently being held by another processes. That means suppose P1 is some process. So this process P1 is the process. So this process P1 must be hold. That is a process. This process P1 must be holding at least one resource. That means it hold at least one resource. And suppose here, and it for this resource number of processes are waiting. That means a process must be holding at least one resource, and this process must ante ikkada enti this process held one resource, at least one resource, and this process waiting for the number of resources. It waiting for the number of resources. That means it waiting for the number of resources. That means ikkada wait chestindi, it is waiting. So these all resources are held by some other processes. These all resources are held by some other processes. So this is called as hold and wait situation. That is a process must hold at least one resource, and this process waiting for the number of resources which are already held by some other processes. So this process P1 use these resources, and that means this process use these resources. When these processes are released all these resources, then only all these resources are available to this P1. But ikkada enti emantunnam, P1 hold at least one process and waiting for the remaining resources. This P1 is held only one resource, at least one resource. So it can hold at a time, it can hold any resources, but here we are saying that minimum one resource. So this process P1 held one resource, and this process P1 waiting for all the resources which are held by the some other processes. So this is called as hold and wait situation. So in these cases also deadlock is occurred. That means the process is never finished. That deadlock in the sense that is initially saying that deadlock in the sense never deadlock is occurred nothing but what, suppose process P1, P2 and so on, these are the processes. These processes never finish their execution. In a deadlock situation, processes never finish executing. So in this situation, there is never finish the execution. So in this situation, here never finish the situation. In this situation, system resources are tied up. Okay, and this situation is called as a deadlock situation. Ante first time antunnam mutual exclusion అంటున్నాం. దట్ మీన్స్ మ్యూచువల్ ఎక్స్క్లూజన్ మీన్స్ ఏంటి, సపోజ్ నాన్ షేరబుల్ రీసోర్స్ ఉంది. సో నాన్ షేరబుల్ రీసోర్స్ కనుక ఒక ప్రాసెస్ హోల్డ్ చేసింది అనుకోండి, సో ఆ ప్రాసెస్ ఒక టాస్క్ కంప్లీట్ అయ్యేంత వరకు ఆ నాన్ షేరబుల్ రీసోర్స్ అనేది వేరే అదర్ ప్రాసెసెస్కి యూజ్ కాదు. ఓకే, దట్ ఈస్ వాట్ ద మ్యూచువల్ ఎక్స్క్లూజన్. దట్ ఈస్ mutual at least one resource must be held in a non-shareable mode. So then the deadlock is occurred. So once it complete అవుతేనే మనకి అదర్ ప్రాసెస్ అనేది రీసోర్స్ యూజ్ చేసుకుంటుంది. ఓకే, కమింగ్ టు ద హోల్డ్ అండ్ వెయిట్. సో ఏ ప్రాసెస్ హెల్డ్ at least one resource, and this process waiting for all other resources which are held by other processes. So in this case, no process, that means P1, P2 and so on, these number of processes are never finish their execution, because one process holds some resource and other processes hold some other resources. So that this is a ever ending, not ending the process. That means it not finish the execution. So this is what the hold and వెయిట్. ఇన్ ద మ్యూచువల్ ఎక్స్క్లూజన్ ఏమవుతుంది మనకి, ఎందుకు ఎక్స్క్లూడ్ కాదు, ఈ నాన్ షేరబుల్ రిసోర్స్ అనేది ఇంకొక ప్రాసెస్కి అవసరం అనుకోండి. సో ప్రాసెస్ P1 రిలీజ్ చేసేంత వరకు ప్రాసెస్ P2 అనేది యూజ్ చేసుకోదు. సో దట్స్ వై ఇక్కడ ఏమవుతుంది మనకి, హియర్ ఇన్ దిస్ కేస్ deadlock is occurred. So in this case deadlock is occurred. Okay, now another one. Okay. So next concept is no preemption. So third situation is called as a no preemption. So this is what the no preemption. Now another one is hold and wait is complete. Now we are moved to no preemption. So what is the no preemption? No preemption nothing but suppose resources cannot preempt it. So here no preemption nothing but resources cannot preempted. Cannot preempted. So resources cannot preempted. So that is a resource can be released voluntarily by the process holding it. అంటే రీసోర్స్ ఎప్పుడు కూడా మనకి CPU నుండి ప్రియంప్ట్ అవ్వవు. సో processes only voluntarily release those resources, then other processes use these resources. Okay, సో అప్పుడు ఏమవుతుంది, అదర్ ప్రాసెసెస్ మనకి ఈ రీసోర్సెస్ని యూజ్ చేసుకుంటాయి. ఓకే, సో దిస్ ఈజ్ వాట్ ద no preemption. And one more is the circular wait. What is the circular wait? So coming to this circular wait, suppose a set of processes are there. Suppose here P1, okay, now so coming to the circular wait, here that that means a set of processes are there, that is P0, P1 and so on. Pn are the processes, so which are waiting processes. These all processes are waiting processes. These processes must exist such that P0 holds some resource. P is waiting for some resource. P is waiting for resource which is held by P1. So P1 is waiting for the resource which is held by P2 and so on. Here Pn is waiting for the resource which is held by P0. So that means what? P0 to P1
next P2, next P3 and so on Pn. Again this Pn is hold for this. That is what here P0 is waiting for a resource held by P1. So P1 is waiting for the resource held by P2 and so on. Pn is waiting for the resource which is held by P0. So that in this case is also the task is never finished. That means all these processes are never finished because which process for executing this particular process it requires some resource. That resource is already held by this P1. Now this P1 complete avali ante, so some resource avasram. So that resource is held by P2. So like that circular cycle is formed. So once it is cycle is formed, no process finished their work. So that all these processes are enter into the deadlock state. So in the previous situation, that is in the no preemption also same. That means resources cannot be preempted. So ante CPU automatic గా preempt చేయడానికి ఛాన్స్ లేదు, preempt చేయడానికి ఛాన్స్ లేదు. So ఒకవేళ P1, P2, P3 and so on, those processes are voluntarily decided to release the resource, then only another process use that particular resource. అంతవరకు యూజ్ చేయడానికి అనేది లేదు. So that's why other processes are never executed. So that deadlock is occurred. That means here all these four conditions must hold for a deadlock to occur. That means first one is a mutual exclusion, hold and wait, no preemption and circular wait. Okay, so that here now see here, that is what that means out of these four conditions must hold for a deadlock to occur. So coming to the circular wait condition implies the hold and wait, isn't it? So coming to this circular wait P1, P2